Hello! Welcome to Teach Me Maths. My name is Jonathan Hicks and we're doing transposition. Now this is video 4, the final one in the series here. Make sure you've watched transposition 1, 2 and 3 first, otherwise this won't make any sense at all. Transposition though is essentially rearranging equations, and so far we've been following 4 steps. Let me quickly remind you what those 4 steps are. So first of all, it's just the same as when you're solving equations. When you're transposing or rearranging equations to get one letter by itself, the first thing you need to do is remove fractions. The second thing you need to do is get rid of brackets. Then you move added or subtracted terms, that's letters to one side, numbers to the other side, and finally you divide by the number next to the letter. Now, so far in videos 1, 2 and 3 of transposition, we've been looking at steps 2, 3 and 4. So we've got rid of our brackets first, then we move the added and subtracted things, and then we divide by the number next to the letter. This is the video where we're going to include the fractions as well, so we're going to do the whole lot. So I'm going to go through a few examples and explain it, but we're always going to follow these 4 steps in that order. If one of these steps isn't there, if there are no brackets for example, you just skip that step and you carry on, that's fine. Alright, so first example, before I give you the transposition one, I want to give you an equivalent example for a normal solving equations thing. So we'll have 2 equals 6 divided by x. So you can see this involves a fraction, and that's all our examples here are going to involve fractions. So the first step is you remove fractions, and the way you remove fractions, if you remember from solving equations, is you always multiply by the thing on the bottom of the fraction. So in this case I want to multiply everything by x because x is the thing on the bottom of the fraction. So do it to both sides. If I times the left hand side by x, I get 2x. If I times the right hand side by x, well, if you imagine a little times by x there, it's going to cancel with this one. Yeah, this is on the top, that x will cancel with the x that's on the bottom, so they're going to disappear. And you'll be left with whatever's on the top of the fraction by itself. And that's very important. You don't multiply an x on the top of the fraction. When you get rid of fractions, the bottom does not multiply the top. A lot of people make that mistake. You multiply by the thing on the bottom, which makes it cancel and disappear from the bottom. You're left with the thing on the top by itself. Obviously you have to multiply by x on the other side though, so the x will appear on the other side. So it kind of disappears from here and it appears over here. But you never multiply by the top. That's very important. Obviously then you go through the other steps, so brackets, no brackets, added or subtracted terms, nope. And finally you divide by the number next to the letter. In this case the number next to the letter is 2. You divide both sides by 2. They cancel, just like these ones are cancelling, which leaves you with the x by itself. And 6 divided by 2 will give you 3. So that's how you would deal with fractions when just solving normal equations. With transposition, remember, it's identical to solving equations. You do it in the same way. It just looks weird because most, if not all, of the numbers have been replaced by letters. Alright, let's try the example. So this is a very famous equation from physics. Velocity in physics is how they normally talk about speed. So you can think of it as speed if you like, but v for velocity is distance over time. So we've got a fraction here, and imagine you were doing some kind of experiment where you were measuring the velocity and distance of some particle or an object, like a car moving along the road for example, and you were trying to work out the time for each experiment. So you want to rearrange this equation to get the t, the time by itself. And remember, I always put it in the top right in a circle to remind myself that's the letter I want to get by itself, because there's going to be a lot of letters moving around in general. Alright, so step 1 is get rid of fractions. So here's a fraction. The way we get rid of fractions is you multiply by the thing on the bottom. Make sure you do it to both sides, just like we were doing here. So I times the left hand side by t, because t is the thing on the bottom. I'm going to get v times t, which you just write as vt. We times the right hand side by t. And I'm not going to write it down each time, but if you imagine a little times by t here, it will cancel with the one on the bottom, and you'll be left with the thing on the top. So vt will just be equal to d. Yeah, let me just go over that again. So I multiply by the thing on the bottom, times that by t on the left, and when you times this whole fraction by t on the right, you're left with the thing on the top, because the t's would cancel. Alright, so no more t's on the right, there's a t on the left. It doesn't really matter. The point is I no longer have any fractions. I've got rid of all of my fractions. Step 2 then is brackets, no brackets. Step 3 is added and subtracted terms, no added or subtracted terms. So the final step, we divide by the number next to the letter. Which letter do we care about? Oh yes, we care about t. So you want to divide by the number next to the t. And the number next to the t is the v. So we're going to divide everything by v. Remember, the letters in algebra are numbers. In fact, in algebra, pretty much everything you see is a number. Yep, the letters just represent unknown numbers. They're numbers we haven't figured out yet. So we're going to divide by the number next to the letter, the number next to the t. We're going to divide by v. And we divide everything by v. Just like over here, we divided everything by 2. Here, we're going to divide everything by v. So divide by v, divide by v. The reason we do that is because these v's will cancel, which will leave you with a t by itself, which is what you're trying to do at the end of the day. Don't try and mess with this fraction over here. Leave it as it is. D divided by v, and that's your answer. You've managed to rearrange your equation. You've got the t by itself on one side, and everything else is on the other side. So you've done it. In terms of transposition, if they ask you the question and use words like transpose, they would say, transpose this equation for t. It just means get the t by itself. This is now transposed. Okay, so if you wanted to work out the time from your experiment, you take the distance and divide it by the speed or the velocity. All right, let's do another example. I'm going to make these get a bit harder each time, and I've tried to include examples that include some things that often catch people out, so that they won't catch you out. All right, next example. This is another one from physics. All of these equations are going to be from physics. You end up having to do transposition a lot in physics. Okay, so s equals ut plus a half at squared. Now, we've done another equation that was quite similar to this on a previous video. This is what's called motion with constant acceleration. So, I don't know if you remember me saying, but on the surface of the Earth, gravity, the acceleration due to gravity is always the same. So if you have an object like a pen and you drop it, then that's constant acceleration. The pen is being pulled down, the acceleration due to gravity, and there's no other forces acting if we ignore air resistance, which won't affect it at these speeds. And then these other letters tell you the other things to do with this motion of the pen falling. So s is the distance that it takes when it falls from where I let go until it hits my hand. U is the initial speed, t is the time, and a obviously is the acceleration. So if you know the initial speed, the time, and the acceleration, you can work out the distance. I can work out how far it is from where I let go of the pen until it hits my hand. But maybe I didn't want to find the distance. Maybe I was doing some kind of experiment to work out the acceleration due to gravity, and I wanted to rearrange this equation to get the a by itself. So that's what we'll try and do. I'm going to put the a here so I don't forget that I want the a by itself. So, step 1, you remove fractions. Have we got any fractions? Oh, hang on, look, there's a half there. At first glance it looks like no fractions, but yes, a half is a fraction. Now I should say there's various different ways you can do this. You don't have to follow the 4 steps I'm recommending in that order every time. There are other ways you can do this and it works. But if you're learning this for the first time and if you're not confident with transposition, I strongly recommend you follow the 4 steps in order because they will always work. So although you don't have to get rid of the half here, I strongly recommend you do. Yep, our first step is to remove fractions, so we're going to get rid of that fraction. The way you get rid of fractions is you times everything by the bottom of the fraction. The bottom of the fraction here is 2, so we're going to times everything by 2. Okay, so we times the s by 2 on the left, 2s. We need to times the ut by 2, that gives us 2 ut, and then we've got this half at squared, which again we need to times by 2. Now there's 2 ways you can think of this. If you've got half of an at squared, when you're timesing it by 2, you're going to end up with a whole at squared. Yeah, this is half of an at squared, so we're going to end up with a whole at squared, a kind of imaginary 1 at squared. We don't need to write the 1 in if we've only got 1 of something. So that's one way you could look at it. The other way you could look at it is, if you've got this fraction, if we're timesing this by 2, if you imagine a times by 2 here, that 2 will cancel with the 1 on the bottom, and it'll leave you with the thing on the top, which in this case is the 1. So you'll be left with 1 at squared. So either way, just make sure you times everything by the number on the bottom, in this case 2. So we times the s by 2, times the ut by 2, we times the half at squared by 2 to get a whole at squared. All right, step 2 is remove brackets, no brackets. Step 3, we remove added and subtracted terms, or move them to the different sides. We do have a plus sign here, so we need to do this step. And this is where you've got to be quite careful. Think very carefully about which letter you want by itself. Is the A you want by itself? So you're going to leave this thing that involves the A. The at squared, that term, we leave there. Everything else that's been added onto it, or possibly subtracted from it, will get moved across to the other side. So we're leaving this, we're taking the 2ut and we're going to move it over to here. This is the change sides, change signs step. So the 2ut, which is currently positive, not because of this plus, remember that plus goes with the at squared. This is positive because there's nothing in front of it. It's the first thing after the equal sign, so there's a kind of imaginary plus sign in front of it. It's a positive 2ut. So when we move it to the other side of the equal sign, it will become a minus, a negative 2ut. The 2s is going to stay on the left though, so it's going to be positive. I always like to write the positive things first, so you don't get confused with the minus signs. So I'm going to put the 2s over here, and the minus 2ut, when it moves over, I'm going to put second. The at squared, which is positive because of this plus sign, is staying on the right, so I leave it there. Great. So there's only one step left. The last step, you divide by the number next to the letter. Which letter do we care about? We care about A. So the number next to the letter, the number next to the A is, now again be careful here, it's t squared. Yep, it's not t. This thing here that's next to the A is t squared, and t squared is different from t. Yeah, all of these letters just represent numbers at the end of the day. If t were 3, for example, t squared, which is what we've got here, will be 9. Yeah, 3 squared gives you 9. So this is t squared, it's different from t. So we're going to divide everything by t squared. So on the left, I'm going to divide by t squared. So you can write a big fraction with a t squared on the bottom. On the right, I'm going to divide by t squared. The reason we do that is because these t squareds will cancel, which will leave you with the a by itself, which remember is what we're trying to do. There's our a. And on the left, don't try and mess with it. Just write it down exactly as it is. So everything we had on the top, the 2s minus the 2ut, becomes divided by the t squared. Yeah, I've changed nothing there. You just write it out again, and that's your final answer. If you want to, you can write it with the a on the left and put all of that on the right. As I say, it doesn't matter which way around these things go. Some people like to have the letter that you're trying to transpose or get by itself on the left. It makes no difference, but if you want to do that, that's fine, you can do that. So those are the steps. We got rid of our fractions by multiplying everything by the bottom of the fraction. We didn't have any brackets, so we just moved everything that wasn't connected to the a directly, that's been added or subtracted to it, to the other side over here. And then we divide by the thing next to the a, the number next to the letter. All right, I'll do one more example. And this final example is going to include everything, all 4 of the steps that we've seen. So if you can cope with this, you should be able to cope with anything. Okay, and this is an equation from electricity. So I represents current in electricity, V is voltage, the big R here, the capital R, represents resistance, it's the resistance in the circuit, and the little r is what we call internal resistance. If you set up a circuit with a battery and some wires and a light bulb or something, then the little r will be the resistance inside the battery. The circuit itself provides resistance, so the wires provide a very small amount of resistance. If you had a light bulb, that's going to provide quite a lot of resistance. But you're always going to get in any circuit a very small amount of resistance that's contributed by the battery itself. And that's represented by this little r here. So in this equation, if we wanted to work out the current, then that would be equal to the voltage divided by the sum of the resistances. The resistance in the circuit plus the internal resistance of the battery. The context doesn't really matter though. I'm just explaining so you can get a feel for where these things come from and where we use them. But imagine we wanted to get the little r by itself. Imagine we were doing some kind of experiment to work out what the internal resistance of the battery was. So we want to find out what this little r is. So, step 1, get rid of fractions. The way you get rid of fractions is you multiply by the bottom of the fraction, and be careful here, the thing on the bottom of the fraction is r plus r. Yeah, the big R plus the little r, That's the thing on the bottom of the fraction, all of it. And you have to multiply everything by all of that, r plus r. So on the left, we multiply by r plus r. Now I'm going to write out something here which is actually incorrect to start with, and see if you can spot the mistake. So I've taken the r plus r, and I've written it next to the I. Does that seem okay to you? Now if you look at this carefully, you can see what this means is that the I is next to the r, so the I is multiplying the r, but there's no I next to the little r. So I is multiplying the big R, but it's not multiplying the little r. This r plus r has to multiply, all of that has to multiply the I. And if I write it like this, it's not. Only the big R is multiplying the I. The little r isn't multiplying anything, it's just sat by itself. Whenever you have a group of things like this on the bottom of a fraction, you want to multiply all of it by something else. The safest thing to do is to put it in brackets. That makes it clear that all of this, the r plus the r, is now next to the I and is multiplying the I. So whenever you have a mixture of things on the bottom and you multiply them next to something else, always put them in brackets. It will save you a lot of trouble. Now on the right hand side, I multiply by the bottom of the fraction, and that's always very straightforward. I'm just left with the top of the fraction. In terms of y, it's because if we're multiplying the left by r plus r, imagine we multiply the right by r plus r as well. The r plus r I'm timesing by here will cancel with the r plus r on the bottom. I'll be left with the thing on the top, the v. That always happens when we remove fractions though. So it's very easy on the fraction side because you're just going to be multiplying by the bottom, so whatever's on the top, that's what you're left with. Don't be sticking any extra r plus r's here. Alright, step 2, remove brackets. So the thing on the outside of the bracket has to multiply the things on the inside of the bracket one at a time. So I times the big R, and then I times the little r. No brackets to multiply out on the right. Step 3, move added and subtracted terms. We do have an added term here, and it's the little r we want to get by itself. So the thing that involves the little r, leave it where it is. The thing that's being added to it needs to be moved over to the other side. So we leave the I little r on the left, leave the v on the right, that's where we want it to be, and the I big R, which is currently positive, again not because of that plus goes with the I little r. This is positive because there's an imaginary plus in front of it. There's no negative sign here, so we assume it's positive because it's the first thing. So the I big R moves over to the other side, change sides, change signs, it becomes a minus I big R. The final step then, you divide by the number next to the letter. The letter we care about is the little r, so the number next to the little r, here's the little r, is I. Yeah. Remember these are all numbers, that's the thing next to the little r, that's what we divide by. And we divide everything by the I. So you divide by I on the left, and you divide by I on the right. The reason we do that is because these i's will cancel, which leaves you with the little r by itself. Don't try and mess with the other side, leave it as it is. So you've got v minus I big R all divided by I. That's your final answer. You've got the little r by itself over here, everything else is on the other side, so stop there. Some people try and cancel these i's, and you're not allowed to do that. The reason is because if you're going to cancel, you need to cancel from everything. You need to divide all of the top of the fraction and all of the bottom of the fraction by the same thing if you're cancelling, and there's no I next to the v. That's the problem. You can't divide this by I, and not do that by I. So because there's only two i's and there isn't one over here, that's why you're not allowed to cancel. But the short answer is, just don't try, ever. When you're rearranging, on the final step, you divide by the number next to the letter, and then just leave it as it is. Don't try and cancel stuff. With transposition, usually it goes wrong if you try and cancel it. Alright, so that's kind of the whole complete package there. We've done all 4 steps at once. Now, if you find that's rather overwhelming, don't worry about it. If you're familiar with solving equations, you're like, okay, I get the solving equations. With the numbers, it's fine. But when you replace all the numbers with the letters, it's like, what's going on? And your brain kind of goes into meltdown. There's a good reason for that. Your brain, at the end of the day, is a pattern recognition machine. You practice doing something, your brain gets used to it, and then you feel comfortable because your brain recognizes the pattern. So once you've done solving equations for a bit, you see an equation, your brain recognizes it, and you follow the steps and the brain goes through the motions because you know the pattern. And that's what makes you feel comfortable. When you see this though, your brain doesn't recognize it. because all the numbers have been changed to letters, your brain just goes, I don't know what to do. It doesn't matter. You just have to kind of overrule your brain and follow the operations anyway. Yep, the 4 steps: remove fractions, remove brackets, remove added and subtracted terms, divide by the number next letter. You're going to feel uncomfortable when you first start doing this. Your brain will not be at ease. Follow the 4 steps though, and it will still work. And then once you've practiced it enough, your brain will start to become comfortable with this as well, because it will recognize the pattern. So don't worry if it feels difficult. It always feels hard when you first do this. Keep practicing it and you'll get there in the end. My name is Jonathan Hicks and you're watching Teach Me Maths.